Let me introduce you to my Warco drill press. But could it be improved? Welcome back to the workshop. So those of you just joining the channel for the first time, quick update on where we've got to. So the idea of this project is we're converting this drill press and getting rid of all those little annoying problems with it. So we started by taking the single phase motor off the back of the machine and then machined all these plates and added this 3-phase motor onto the top. Then on the front of the machine we've got this brake assembly such we can lock out the table and lock the knee off when we're doing our drilling operations. We also added this cover that hides up the bevel gear assembly inside there, just to keep all the swarf out. And then we added this drive assembly on the side, so we basically got 2 bevel gears in there that drive the ball screw. So you turn the handle, turns the ball screw, runs through the ball nut, and that moves that block up and down, and that block will be connected to the back of the knee, just to raise and lower the table. On the front of the machine here, you can see this custom box that I made quite a few videos ago in one of the early videos in the series. So we've got start-stop, we've got the variable speed control for the 3-phase motor, forward and reverse, the jog buttons, and then the e-stop. And then that's connected via this cable here back into the main control unit. So then we've got a custom control cabinet here. So we've got the inverter that runs a 3-phase motor. There's the mains coming in here with some motor temperature sensors and so on. And at the top there you've got the logic supply for all the switch gear. So on the side here you can see the digital readout display. So the idea is we'll have the readers on each of the axes. So we'll have X and Y on the main table so we can see where we are in this sense. And then the Z readout will be for the knee as it moves up and down by that ball screw. Then in addition up here we'll have a little readout for the quill, just one of those simple little readouts that you see on many machines, just so we know where the quill height is. So as you'll see from the thumbnail on this video, rather than make an XY table I've decided to buy one of those ready-made import ones. I've got it over on the workbench, however I've somehow managed to take it completely to pieces. So to see how we got to that condition, let's start the video. So a key part of this drill press project was to have an XY table so I could move the work around in 2 planes and then draw hole patterns or whatever using a DRO. Now the original plan was to build that from scratch, so buy aluminium parts, buy ball screws and basically make what you see before you here. However, 2 things have changed my mind. One is the cost of aluminium is pretty expensive, so to buy something like that, 20-25mm thick, it was going to cost quite a little bit of money. And secondly, this project's already taken enough time. I thought I'd have a look and see what's already out there and see if there's something suitable. So the obvious place to start looking was the milling machine tables, especially the spare parts for the small hobby machines like the Sieg machines and so on. Now 2 things against them were relatively limited travel actually, and they were quite small overall, and they were pretty expensive. Now granted they are designed for milling machines, they'll be very accurate and ground in and everything else, but this is a drill press machine where I just need reasonably accurate but not super accurate positioning. So I started looking a little bit further afield and came across this series sort of on eBay. I'm sure you've seen them yourself in this kind of striking red and green finish. And the main thing that attracted me about this series of XY tables is the price. This particular model was £225, which is about this many dollars. So when you factor in the cost of all the raw materials and my time, I think this is pretty good value. However, key thing is it any good? So we're going to strip this one down, we'll have a look at how it's made, have a look at inside, and we'll have an attempt at some measurements because really we want it to move this way and this way 90 degrees to each other. We want it to move in a reasonable straight line. So let's dive in and we'll start off with the specs, what you actually get for your money. So the parts that come with it are, you get these handles, you have to put it together yourself, but that's no problem. The handles are on there, you get the keyways, there's various bits of hardware in there, put it all together. As you can see I haven't opened this yet. The colour of the bag is interesting, it's that encouraging mix of grease and rust, but I'm sure it'll all clean up. That's what you get hardware wise. And then the XY table itself, it arrived in a very nice, very strong wooden box Well, I say strong. This lead screw had punched its way out through the wooden side. I know they put some cardboard in there to try and stop it, but it obviously had quite a heavy shunt, and it managed to work its way straight through the pretty thick wooden sides. Same on the lead screw, I think it was this end. It also tried to punch its way through the box. But it looks like it's arrived in good shape, and we'll have a look, but at the moment it moves reasonably smoothly, so I think the lead screws are okay. And this is what you actually get. Okay, so let's look at the overall specs of this. So I can certainly tell you this is heavy. The specs say it weighs 38 kilos, and I can just about lift it up onto the bench. It is very heavy. What about size? So let's get our tape measure out and have a look. Have a look at the sizes. So in terms of overall length of the table, 552 millimeters by, say, about 194. So that's the size of the main table. We'll do the travels in a minute. And then the size of the base. So front to back, we're talking about 315. Can you see it on that? Yeah, 315 front to back. Uh, 295 from there to there. Okay, so that's the rough footprint, and then the holes in the bottom there. You probably designed with a bit of tolerance, put a 10mm bolt through there, obviously with a nice big washer. And what else we got? T-slots themselves. Actually, let's get something better. T-slots. Hopefully they're a standard size. Yeah, so 15 wide. Complete depth down to the casting at the bottom. 14.3, so obviously you'd have a little bit of clearance on that, and then, don't know if we can do the width of the slot, we're going to have to estimate that. Say about 24. Casting's a bit rough, so it's hard to be sure. Yeah, about 24 at the bottom, so there'll probably be a T-nut that's just got a little bit of clearance on that. So those are the base sizes, and I'll say 38 kilos is how much it weighs, so it's pretty hefty. So first impressions, looks okay for the money. Okay, so let's have a look at travels. So one thing you'll notice down here, I've just made these two black marks because that's about as far as it wants to come this way. If you look inside the machine, I've tried to get some shots just inside, not easy. It looks like there's nothing stopping the table coming all the way off the lead screw. There's no little catch or retaining system on there, so I may end up adding a little bracket just down here just to stop it winding all the way off there. So now we've got those reference dots, let's see how far it will go that way. I'm going to cheat a little bit and just use the drill. About there. Right, let's measure it and see what we've got. Okay, so complete X direction travel is about 260 millimeters. So 260 side to side, so not too bad. And then that's the X direction, about Y. So for the Y direction, this is always the limitation of any milling machine, and it's no different here. So this is going to be a shorter one, obviously, so I'll just put the two dots again. We'll go the right way. Oh yeah. I think it's probably going to come back of the nut. Just trying to have a look inside. Oh, there's the answer. So that has moved roughly, let's call that 140. Not too bad. Okay, so we got, let's write that on there before I forget. If you can hear that, sounds like the birds are having a party outside. Okay, so we've got 140 by 260 complete travel. Now we're going to go out to that full extent. Let's just talk about just sort of initial impressions, initial quality and so on. This, I don't know about you, with this green like hammerite paint reminds me of something from the kind of 80s. It's not a particularly nice finish. I think we can do better than that. Similarly on this plate here, I've actually taken it off. It's quite a thin metal plate. It just protects some of the swarf dropping down onto the lead screw. Obviously it doesn't give you that protection there, but when it's at this point here it gives you some protection. But they can't make it any bigger because this would come along and hit it and limit the travel. Now we've got that nice finish on there. You can see the finish on some of the castings. It's okay. The way the paint was applied, it's ran over some of the edges. Some of the finish on this casting here, bubbly I think is the technical term. You got that. The other thing I noticed was, again, you got this lovely hammerite paint, which I'm really not too keen on. So I think that'll be the first thing to go. So where these bolts go on the edge here, they come all the way through into the casting. Not a disaster, but if you wanted to use this with flood cooling, obviously some of the coolant would go down here and probably leak out there, so you'd want to fill those up there. Yeah, not a big deal, because we're probably not going to use flood cooling on our drill press, but one to note. But then the table itself, it feels reasonably flat, so we'll find out. A few little extra bits of paint thrown in for free, just around there. Just general, built to a price, probably by someone not paid particularly well. Bits and pieces there. And if we just zoom in on the lead screw, I think that's just grease. I don't know if it's bits of swarf as well, can't really tell. I could do with a bit of a clean and a re-grease. Yeah. And then the last bit, the sliding surfaces. Now, this is part of the reason why this is built to a price. You can see this has just been milled on a milling machine. There's no scraping. It's not a precision milling machine table. And then on the dovetails, which is what it actually slides on, again, I think it's just had a dovetail cutter come down there. It's not been ground or lapped. So the precision of it will just rely on that, the finish on that surface there. You've got the usual gibs in there just to tighten the whole thing up. Now at the moment they're quite loose on both axes, so that all needs just dialing in. Got the same thing going on this side as well, same finish. I'll just show you underneath. Yeah, it's a bit dark in there, but that's not scraped, that's just off a milling machine. Yeah, that's what you're getting for your money. In terms of the other hardware you get on here, so these two are the locking screws, so once you get it in position you just wind these in and they just push onto the gib, which is just like a metal strip like you can see down there that just locks the slideway up. And then you've got the remaining 4 screws. These have got little slotted heads like that, and the idea is you just adjust those in until you get just the right amount of pressure on that gib so it slides nicely but not too tight. And then over time it wears and you have to adjust those, so you lock them off with the nuts there. So we'll come back to those in a minute because we need to do something there because we've got to fit DROs onto this. And then you've got a similar thing on the y-axis, so you've got the 2 sort of thumb screws there that lock that gib into place when you want to lock that axis. And then you've got 1, 2, 3, these are the gib adjusters here, so you back that nut off, wind that little slotted screw in until you get just the right amount of pressure that you want on that rubbing strip there called the gib. And you do that in 3 places and then lock the nut off. So, pretty standard stuff really. And again, we need to come back to that because we need to fit a DRO onto this axis as well. Let's talk a little bit about digital readouts. So you might have seen me review these in an earlier video. I'll put the link in the description down below. These are sent to me by Banggood. So there's 3 of these and then the digital readout as well. And the way these work, in case you didn't know, just very basically is they just read the position of this head relative to the main body there. Now it doesn't matter if the main body moves like that, or the head moves like that. As long as you've got relative motion between these two parts, you'll get a reading on the display. The main thing to note is, see, you've got this kind of yellow protective strip down here that opens up to allow the reader head to go in. You really don't want to get anything inside here, so you want to mount them like that with a cover on, or ideally facing down if you can, just so any swarf and stuff can't get in there. So when you come to mount them, so in terms of mounting them, there's two options. They can go on the front here, or they can go on the rear edge. Now the problem with putting them on the rear edge is you're going to lose Y travel, and as you've seen, we've only got 140 millimeters, so we're going to lose this if we're not careful. So I really don't want to do that, because I need all the Y travel I can get. So then we're forced into having a look at the options at the front, and as you can see, I've got to mount something on here, probably the main body, and then the reed head down here, because these two move relative to each other, and the whole space is occupied by gibs or the locking screws. So I was having to think about exactly how I'm going to do this, and I've not decided exactly how, but I'm definitely decided it's going to go on the front here, and I've just got to find a way to do it. The other problem is this is relatively wide, and it's much wider than this section here, so it's going to end up hanging down a long way there. And so by having the bottom flush with that and no further down than that lower edge there, this I think is going to stick up over the top of the main table, which I don't really want to do. So I'm still looking into options. Actually, having said that, I think it will. I can't really tell because these are in the way, but I think if these are out the way, I can get it so this top edge is flush or under flush with that, and then that lower edge, just having a look at it. Actually, yeah, I think it will just be under. So now we've got the main problem of what to do here. So my current thoughts are, so let's just see this, the reed head itself, I think it's more or less 80 millimeters, yeah, 80 millimeters. So I think I want to put the reed head this end, which puts it about there. Now, if I can get away without sort of relocating this, that would be ideal. Then I've just got this one gib screw at this end to worry about. So obviously I can't have that there at all. If I put it fully on, then I'll just lose both these, which start to get a little bit more tricky. So again, I haven't fully decided, but I think what I'm going to do is have it so that the reed head goes from about there to there. We'll lose this gib adjuster from here, and then, well, it's just an idea at the moment, drill in from the end, and then inside here make a kind of a cylinder with a tapered end on it, and then have it such that probably even have a hardened ball bearing in there, so that when I screw this in and out inside here, this screw in and out, it will push on that ball bearing, and then that will, through kind of wedge action, that will push that gib, the gib screw in and out, or the cylinder that's in there in and out. So it'll kind of work sort of like 90 degrees inside this section like that. So the more you push it in like that, the more it pushes it onto the gib. So sort of like that action. So there won't be anything here at all. I've never tried that before. I don't know. I need to drill pretty accurately into here to hit the center line of that. But it's a thought at the moment. But I'm determined to put the reader on the front here so I don't lose all that travel. So I haven't fully decided, but that's kind of where I'm at with it. So that's the x-axis. I had a look around online and had a look at how other people do it, and generally they put it at the back and then they lose that travel, or they've just got a little bit more space here because it's a proper milling machine. If you can link me to anything that's, or if you've got any ideas yourself about how anyone's overcome that, it'd be great to see it. Right, so that's the x-axis. So the y-axis is a bit more straightforward. So this is the y-axis reader, because obviously you can see it's a little bit shorter. This is the reduced travel. Now the main unit itself, it kind of lends itself to having the main body on there, and then having the reader on that, and like that. That's how it would like to sit, I think, because this is quite large and that's quite small. Problem is you're going to have all the swarf and stuff going into there. Yes, it could have a cover on it, but you know, it doesn't feel like the right idea. Another option which I quite like is to have it like that, and then, because there's nothing over here, although having looked at it, actually when we're fully across, the handle's going to get quite close. Yeah, so I had been favouring that idea, but now I look at it, that's not so good either. probably going to limit the travel by the handle hitting that part there. But that was another option, and then we'd have a bracket coming off there onto there. If we do it the other way, such that this part's on the moving piece, that's sort of like that. Well, that would be okay, but we'd end up having a bracket holding this, and when it's fully this way, this will kind of stick out quite a long way, which is not perfect either. I guess I could have a look at see what's behind the machine and just see in CAD if I could have it like that, and then have the head on the lower part via a bracket like that. But again, we're getting quite close to this, so if I get it to work that way round, I think that looks like the best option. It's just getting a little bit awkward with it all. So again, I need to have a bit of a think, but determined to put it this end because the other end's full of all the gibs and adjusters and so on. Okay, so I think there's only one thing left to do, and that's to take it apart. Before we do that, I think I mentioned earlier it comes without the gibs adjusted, so as you can see you've got that free play movement, so everything needs to be tightened up. But we're not going to do that because we're going to do the exact opposite and we'll strip it down. So these are the lock screws, nice and easy. I imagine these are all identical, but I'll keep at least these 4 together again on this side. They weren't actually that tight. I don't think they'd been locked off. Got to take this thing off. I don't know about you, but I'm not super keen on this green. I'll either make a new one or just strip this off and repaint it. Okay, so it's just a bit of sheet steel. Looks like, yeah, the holes have been drilled, not step drilled, but that's just a regular twist drill, isn't it? It's made a triangular shaped hole. Nice burrs on the bottom. But you know, again, built to a price, so that's that bit. Now we're in here, you can see we got, oh, which way is it? Here we go. Nice little thrust bearing, so that's nice to see. A tiny bit of, no, not much end flow, but again, these are probably not adjusted. But strangely, it's probably about 0.5 millimetre of side movement. And why would you do that? Is that just to allow any tolerances? To sort of self-align. I suppose as long as it's constrained in this axis, probably not too critical. Yeah, because it doesn't want to go in and out. Let's take this off. Oh, we've got an all. We'll check where that goes and make sure that's clear as well. All right, let's take these off. Now to get these off, you need these hook spanners. So the smallest one I've got is 22 to 26. Now I've just got a set of, but they go up in size, so I'm going to have to use the 28 to 32 to hold it. That's not ideal. I really want 2 of these, but I don't have that, so I can't. So, oh, got that wrong way around. So these just hook into those slots. Oh, it wasn't that tight. And then you can lock off to get your preload. And then this should come off as a whole unit. Oh, again, wasn't that tight. It's a little sticker. Katsu Tools, made in China for AIM. So AIM was the, I guess, the UK distributor, which I think I bought it off. Just holding that on. Ah. Okay, it's got little roll pins down here. Yeah, it's going to be like that, is it? Okay. Yeah, it's in pretty tight with those roll pins down there. And Could be a bit of a pain to get that out. Right, while we think about that, we'll just strip down the other side. So it's the same thing over here. There's two little lock nuts. Is that going to get it? Okay. Oh, well that's part of the bearing. Okay. So there's the thrust bearing. Okay. Now you can see the other part of the thrust bearing there, but it's okay, the balls are in a cage, they won't fall out. You also see the oiler there is quite proud of the surface, not quite sure that's fully gone in. Probably going to have the same problem this side. It looks like it's got these little dowels holding it in. It's pretty tight. I think what we'll do this side is wind the whole thing off. It will come off the nut, and then we'll take the table off completely, and that might be give me a bit of access to try and get this off. Okay, so somewhere around here it should start coming out of the lead screw, should come out of the nut that's underneath here. Wow. Yeah, it's got some gravity to it. Let's see what we got. Okay, so here's our lead screw with the two thrust bearings. Probably just about take that off, so we might be able to knock that off now. I've got good access. Lead screw there. Yeah, it's just been milled, and then you can see the rough casting down there. Now we're in here, you can see, yeah, that's pretty rusty. Could do with a bit of something on there. Quite a lot of material on the lead nut. Plenty of grease on it, so I think we'll leave that where it is. It's obviously got reasonable alignment. And then here's our gib. It's got a little hole drilled in it, which looks like, yeah, it lines up with that one, which probably means that helps you. Is it square? Yeah, it's just square, isn't it? I've just marked the end of it there, black, just in case it was tapered or anything like that, but I don't think it is. And then that hole will allow me to line it back up again. Okay, so that's what we've got. Right, let's see if we can get the thrust bearing out, which we can. Looks like that. Just a little cage that holds all the balls in, plenty of grease in it. Yeah, looks okay. And then the lead screw should come out. I think there's another washer just in here. Or is there? Yeah, that's the other side of the race. Here it is. Man, that's full of particles and stuff, so we'll give that a bit of a clean. And then the lead screw itself. And now you can see, just do a little bit of cleaning up on the keyway there. Otherwise, yeah, it looks okay. Right, and then that's managed to get painted green as well. Well, some of it has. There's a thrust washer for the other end. Okay, and that comes up against that little shoulder. Right. And that's what we have. You can see where it's been turned on a lathe and then probably just had this bit cropped off. There's the roll pins. Nice and simple. There we go. Now, does that oil port there, it's not flush to the surface. Probably okay, to be honest. Well, it might leak out just slightly there. And yeah, that does go down and feed the thrust bearing through there. Well, that'll feed the one on this side. I don't know about the one on the other side. I guess, yeah, you could probably get to that if you extend the table out and oil it from underneath, I guess. Right, well, now we've broken that down, we'll give it a clean up. We need to get the other one off on the other axis. And then we can get this green stuff off, make it look a bit nicer. Okay, I haven't shown it, but I've just undone the hardware on this side as well. So you can see all the Gibbs screws there and the locking screws. So we should be able to take the gib out this side. Oh, this one's actually got some oil on it. The other one was bone dry. Again, it's simple square. And again, got a little hole there. By the way, if you buy one of these, you don't have to do all this. This is obviously saving you the bother by me doing it for you. So you can have a look at what's inside. Decide for yourself if you want to take it apart and clean it, or just go with it. Alright, here we go. Here we go, it's out the pins. Be careful the thrust washer doesn't fall off the end. Here it is, there's plenty of oil in there, that looks okay. And there's the other race for the thrust bearing. And again, our main housing. Still not keen on the green. So I'll just wind the lead screw out. Again, similar to the other one, the longer one. Needs a little bit of deburring on there, but otherwise looks okay. Just needs a bit of a clean up really. Yeah, I'm not quite sure why they allowed quite so much lateral movement other than just to get it nicely lined up. Anyway, it is what it is. Okay, so all we need to do now is, oh, I say slide it off, but the nut's probably going to be in the way, isn't it? I'd guess. We've gone this far. It should come off now. Just mark that in case. Yeah, I think it's offset to one side, is it? Yeah, it is. So it'll only go on one way. And that is just yuck. I know you can't see that on camera, but man, that is just full of dust. And yeah. Okay. So there's nothing holding this side out. Here we are. Ah, looks alright underneath. Nicely machined there, flats. And if you can see where the gibs run, actually, maybe they have been ground. Can't quite tell, and this is heavy. Right, let's put it down. Okay, so we've broken it down into its main parts. We've got the base there. There's the long table, so it's moves in the x-axis. There's the carriage there, the intermediate carriage. It allows it to move in the y. Yeah, do you know, I've got a good feeling about this. I think it's going to be alright. We'll just give it a clean up, make it look nice, get it all oiled, adjusted, dialed in, and then we can do some accuracy tests on it. Yeah, a bit of deburring on some of these sharp edges. Don't know what we'll do about this plate. Maybe make another one. I don't know. Just yeah, not decided. And then while it's in this state, it might be a bit easier to offer up and start drilling for where the DROs are going to go. Just sort of work all that sort of stuff out, and then I can get some proper measurements for these holes and where they are, so we can get this into the CAD. Because then I can make sure the table that it sits on is going to be about the right size and the holes are in the right place. So there you have it. That's what they look like when they're stripped down. It's all right. It's all right. So we got time for in this video. Join me again in part 2 and we'll start tidying this thing up.